Good evening. I Manjunath, Assistant Professor, Department of Physics. Here we are learn about how to use the Gaussian weave, where we can study the molecular structure, bond length, and their ground state energy levels and ground state energy. So to study that, we need Gaussian weave software. We have already that. Just by clicking that, we get that software is open. Initially, we can see the two windows like this. And here to select the or choose the molecule or an atom, so first we have to select this one. So here I'm talking about ethylene. So for ethylene, we know that there are two carbon atoms are there like this. We have two carbon atoms are there and four atoms are there. So we have to select the four hydrogen atom. So like this, one is here, another one is here, and another one is here. The last one is like this. So now after this, we have to choose the appropriate bond length. Uh, to choose the bond, uh, we have to select the two atoms here. One is this is the hydrogen atom, and this is carbon atom. Between carbon and hydrogen atom, we know that there is a single bond, and here also we have a single bond, and finally from here to this carbon atom, once again we have a single bond. We can choose that single bond like this, and from here to here, by clicking the two molecules, we defaultly will get the bond semi-chem. So here we once again we have single bond, but for the time of two carbon atom, we know that there are two bonds are there between the carbon atoms. There we will get ethylene molecule, and however the atoms or molecules and bond length are irregular in manner. So to calibrate that, we have to select this edit and click this. The bottom we will get the clean option. Once if you click the clean option, the molecule or an atom or an chemical which is arranged default size and shape, and where we can observe, we can also observe the three-dimensional view of that molecule. So thereafter, so once if we clean that, the exact bond length and exact distance will be arranged like this. Thereafter, to study the energy or to study the frequency and all those things, we have to go for calculate. Before that, in the weave section, weave tab, by selecting the weave, we'll label the molecule. Uh, we can mention the symbols also. There we can know the symbols. Carbon, we know the carbon atom, 1 and 2 carbon atom, 5, 6, 3, 4 are the hydrogen atom. So thereafter we can to study the energy, we have to select the calculate option. There Gaussian calculate setup. Okay, once if we click this option, where we can use the options to study the energy and frequency. There will get energy, frequency, or optimization frequency, both NMR, stability, whatever. So here I'm just let you know the how to calculate the energy here. So to select the energy, here we have to select the energy, and method is the Gaussian state itself. Let it be as it is, and go to the link here. So here we have to select instead of default name, we have to select the specified name. We can give the specified name here. First we have to erase the chk file name, and we can give the specified name as ethylene like this. As since as we are studying about ethylene, I just give as ethylene like this. and thereafter, so click the submit option. Soon after the editing the name, we have to choose the or select the appropriate path. Here I'm just uh, select a desktop as in to save the file. So once again, I give the same name ethylene and click save. So where I can save the file, and now we can click the submit button. Soon after the clicking the submit button, once again it will ask to give the name once again. Give the same name ethylene again and click save. Soon after clicking the OK, the program is run as like this. So by using these data, we can study the various things like energy, frequency, optimization, NMR, all those things. And soon after clicking this, we'll get the same molecule which is opened in another window where we can observe here like this. By using this CHK file, one can easily study the LOMOS and HOMOS. Here I'm just let you know the HOMOS, how it looks, and what is the bond length. We can observe the bond length here at the bottom. By clicking the two molecules, we can observe the bond length between the two molecules here, like bond length or bond angle, whatever. See, one can observe here. This is what the bond length between the hydrogen and carbon molecule. Once again, the same manner, another hydrogen and another carbon molecule bond length is like this. And to study the bond angle between the two hydrogen atom and one carbon molecule, we have to choose the all the three molecules like this, and there we'll get the bond angle as 120 and 120 degree. So from this we'll know about bond length and bond angle. Okay. Now let us talk about uh, the homos and lomos calculation part. Soon after knowing about the bond length and the bond angle, we can also know about the energy. To know about the energy, we'll go for the result, and if you click the summary, you'll get the tab like this. So there you can observe the total energy. It is atomic unit, this much of atomic unit. That's what minus 77.59 atomic unit, and there is no dipole moment. And this is what the essential data where one can use for the further calculation. And thereafter, we can also calculate the uh, one can also study the homos and lomos. To study the homos and lomos, we have to close this option because with this option we can't able to study that. So to study that, we are already share saved file is there. It's a .chk file where you can observe that chk file. Just open that chk file, and from that chk file one can easily uh, study the homos and lomos. So here, by opening this, we get the toolbar. From there, we'll get homos and lomos. We have more MOs is there. If you click this, we'll get another tab which is visualized as like this, and where you can observe the homos and lomos. Here I'm just show you the lomos. So after clicking this, go to the new Gaussian MOs, and here if it is selected default load MOs form exists CHK, let it be as it is. If it is not, you have to select default like desired. Thereafter, new AMP AMPAC MOS. Here also once again load MOS, and thereafter you can click OK. Once if we select the load MOS, we have to click load here. Soon after clicking the load, you'll get the visualize option. We have to give the update here. Once if you click the update, you can observe the changes which is happen in this molecule like this. There you get the Lomos where we can observe like this. And if you want to save this image, you can save this image. Once again, you can give the path in the desktop itself. You can save the image. Further, after saving this image, further if you want to know about the specified view, you can go for the display view and go to the display format where you can get the more option here: general, quality, molecule, text, surface. If you go for the quality, you can give the different shape of an this hydrogen atom, where the molecule you can give the tube structure, or you can give the ball bond structure, whatever. You can also give the covalent bond like this. And if you go for surface, you can give solid mesh. If you give the mesh option, it will be visible as like this. If you give the solid, it will be looking like this. If you give the transparent, it will be looking like this. Even in transparent, you can give the opacity in a different manner as you need. And here also we'll observe the positive molecule only, or else we can observe the negative molecule only, or one can observe both molecule. So for sake we can observe the mesh, it will be looking like this. And you can give the Z clip also. That means if you give the solid, here you can find the difference, where you can observe the inner molecule also. And if you want to change the background color, you can go for the general, where you can give the background color your desired color as like this. This is cyan color, or you can give the black color, or you maybe let it be default also, right? So this is all about the how to weave your molecule with your desired color and homo like solid or mesh, whatever. After selecting the desired background, we can also study the homos lomos from these highlighted icons. That's what alpha MOS. Here these two are gives the homos and lomos. Soon after clicking the update, it will update it, and you can save this image also for your to add this to your paper or journal. And this is all about how to use the Gaussian for to study the molecules and their energies and all those things. We will look at about frequencies in the next video. Thank you all.